So I'm here to connect with everybody and see old friends, and it's the one time of the year where it's like a reunion, and you see everybody, you talk to everybody, and it's amazing to like just connect. It's a total exhilarating high to be here for a couple of days every year. You can't walk 5 feet without running into somebody like, hey, big hug, and you talk to people. It's great.
Seeing familiar places and seeing new faces and having the opportunity to connect with people that are also so passionate about what I'm passionate about. But then in addition to that, all of the networking and business opportunities are always amazing. We always have the best leads come out of AWE every year.
With any conference, and probably specifically like this one, the fact that you can come to one place and see hundreds of friends from this industry, right? That's really what brings people together. It's the happiness of the community. To communicate face to face, to be able to shake hands and give hugs and have drinks together. That's something that's hard to do in an online forum.
Welcome, everyone. Happy Thursday. Let's get going. Thank you all for coming to learn more about how to get started with HaptX and everything that you need to know about adding touch to VR. Now, this is a specifically special and fun topic as we all look to make VR experiences as immersive as possible. And by adding that key sensation of touch to your experience, it becomes that much more realistic. So you're all in for a treat today as we learn more about haptic feedback from our esteemed panel. Before we do so, let me introduce myself. My name is Nate Harper, Director of Business Development at AWE. And you all, of course, know of our 3 major events in XR around the world, with our 15-year anniversary coming up in California this June. However, we also host educational content just like this and even local networking events around the world in over 30 cities. So make sure to see what's near you by going to the AWE website and clicking on the AWE Nights tab to see when you can make one. But without further ado, let's get into the fun stuff. Let's talk about haptic feedback. And I'm really excited to introduce you all to Linda Jacobson, who is the Director of Marketing at HaptX, and will be introducing our panel for today.
Thanks,
Linda.
Nate. Thank you. Hello, fellow believer in the power of immersive computing. We are so glad that you're here to explore creating multi-sensory, multi-user magic in your virtual environments with us. Yeah, I'm Linda Jacobson. I'm a member of the HaptX team, and I'll be hosting our live chat on our YouTube stream if you'd like to comment or ask questions, which my colleague Caitlin Franz will share with the other presenters near the end of the session. So let's get started. Please meet HaptX Product Manager, Caitlin Franz.
An amazing panel of haptic experts, including my colleague Andrew Dunner, who is a technical environment artist at HaptX, and Kip Haynes, who is a lead creative technologist for the Lowe's Innovation Labs. And joining us remotely, we have 2 more panelists. We have Austin Arnwine, who is an instruction technology lead for Oak Ridge Enhanced Technology and Training Center. And we also have Chris Mendoza, who is a multimedia artist at the University of Central Florida Institute for Simulation and Training. And we're going to get into a whole bunch of topics, but all related to adding haptic feedback to virtual reality, because the physical world around us is made up of a ton of different sensations, including touch, heat, sound, and even vibration. And they all play a huge part in the way that our brains, us, our muscles all interact with, remember, and enjoy the world around us. And one really simple but great example of this is this water bottle in front of me. If I hold this water bottle, I can tell without even touching it that it's a water bottle because the shape prevents my fingers from closing in farther around it than its physical body is. And that's an example of force feedback, which is a type of haptic feedback. When I grab it without looking, I can even recognize and interact with it. I can take the lid off if I wanted to, because the different features of the lid and on the bottle displace my skin in a way that makes me recognize it as a water bottle. And if I run my hand down the side of it a little faster, it will vibrate my skin across the texture and across the label, which is just another piece of information that tells me that this is my HaptX water bottle. And some of the most common types of haptic feedback that we're used to are in, for example, our phones when we get a notification, or in a controller. The buzzing and vibrating we're all really used to are common in human-computer interactions, and especially in immersive computing. And those other types that I talked about, tactile feedback, the force feedback, the vibrotactile feedback, we can do with gloves, which Andrew is wearing our glove and can tell us a little bit about how it works.
What we have here is one of our Haptics gloves. This is from our DK2 units, which are our development kit 2 units. And what they feature are tactors that are in the palm and in the fingertips that actually inflate through pneumatic pressure and actually displace your skin so that they actually push into your skin as you touch something. We also have these tendons on the back that give force feedback to resist something. So like with Caitlin's water bottle, as I grab something in VR, it can stop my fingers from passing through that and give that feel of force feedback. We also have a Vive tracker here, which gives us a global positioning. And then we have magnetic sensors here that gives us very accurate positioning for where our fingers are. So we can animate our hands in a very realistic manner.
Thanks, Andrew. So for many cases, the controller works really great. We're going to talk about how well it works for development for when you do intend to use gloves eventually. But for many workers out there doing training and simulation and interacting in a virtual environment, you need the force feedback, the tactile feedback, the vibrotactile feedback, all of those more detailed clues into what you're holding and how you need to use it. And all of those work together so that we can train people to do their best work. And the panel that I have here today is able to put all of these different types of feedback into their virtual training simulations with the HaptX SDK, which has a C++ API and an Unreal and Unity plugin. So you can use those different environments. And Kip, you have actually a great example of an environment that is using all of these different feedback in a virtual simulation, the Infinite Kitchen Touch. Before I ask you a little bit about that project, can you tell me more about your team at the Lowe's Innovation Lab?
Yeah, absolutely. Lowe's Innovation Lab, if you're unfamiliar, we're a group of technologists, researchers, engineers, artists, creative technologists, I guess, just engaging with emerging technology in the areas of machine learning, computer science, artificial intelligence, XR, VR, large language models, and even haptics. And really just trying to envision what the future of home retail looks like. And it's a fantastic team. And I just want to mention, I'm so fortunate to get to talk about their work in a sense. But I just want to call out 2 of my teammates, Phil Harlow and Deanne McGann, who were largely influential in this prototype. And I know you guys have met them because they've been in here so much testing things.
Awesome. And the Infinite Kitchen Touch is a great example. Can you just describe a little bit about it?
Yeah, sure. So it, as you mentioned, it is a kitchen experience. And so Infinite Kitchen Touch, it's a touch-driven design, kitchen design experience prototype. And before I talk about the specifics, I kind of want to give some context, like why is Lowe's building experiences like this and trying to understand these kinds of things. And really, I think that the story of this prototype it really begins in the store. I love watching our customers interact with products in the store, especially things like textiles and home interiors and appliances. And we know that the sum of our perception and our understanding of the world kind of comes through our senses. It's this idea of like embodied cognition, if you will. And we know that touch especially helps us engage with products. It can heighten our sense of engagement. Touching things can help us understand how things work and even give us confidence in the quality of products. And also, it can give us a sense of ownership. When we're able to touch products and see how they work, we feel like we can envision ourselves owning them. And really, part of this story also is that the customer journey really begins in the home. And just think about like the last few years, how all the crazy things we bought online. I mean, I bought huge things for my house, furniture and things like that I probably would have never even thought about before. So, and we know that trend's going to continue on. And so, Lowe's and the labs are interested in how we could engage with our customers and help them experience products, even in their home in a tangible way. So with that in mind, we built Infinite Kitchen Touch prototype, which is scrolling here. So it's a fully touch-driven interactive kitchen design experience. You can touch everything. You can touch the counters. You can pick up plates and bowls. You can wash your hands in the water. You can feel the water coming out of the faucet. It's got appliances that all function and work. So you can turn things on. There's levers. There's, and everything feels and sounds like it should because it's haptics driven. And there's even food items. So you can take an egg and crush it in your hand, or you can, bake a cake with it. And that was a lot of fun working on those things.
Yep, I got to watch a lot of people go through it at AWE, and there were smiles all around. It was definitely a super enjoyable, fun experience with lots of different experiences of touch in there. And that's a really great example of like a retail experience that you might have. I know that you're maybe have some ambitions, some thinking about some training examples.
Yeah, for sure. And actually, there's kind of two motivations behind bringing this prototype about. The first thing is just, we just want to understand what it means to build a touch-first driven experience. Like that's kind of new territory, I think, and just understanding that. There's also product avatars in the space. So what does that mean to create digital assets that function in a way? And also, we wanted to understand how adding touch to a virtual experience adds a sense of engagement. So we did a pretty significant study, actually, about 100 people. We actually did the study right here in your office, just trying to objectively understand, okay, like what does adding touch and haptics really add to a user sense of engagement?
Yeah, I'm very excited to see the results of those when those come out. So as I mentioned, you guys are thinking about training. A lot of people we know are thinking about training for adding haptics to VR. And another great example we have is the example of using a glove box, which is something that not a lot of people have experience with, but Austin is here to tell us a little bit about that project.
Yeah, absolutely. So when we're thinking about glove boxes in general, and to give some background of who I am and who I work with. So I'm from the Oak Ridge Enhanced Technology and Training Center, and we are a part of the Department of Energy. So glove boxes in particular is a mechanism that you can use as an operator to be able to monitor and manipulate certain materials that could be hazardous in a very safe way. So whenever we found using this type of technology with HaptX to be able to think of training in a very concise way, but also in a very safe way, it seemed like a perfect fit, especially the fact there's already a glove integrated inside of this glove box scenario. So we're very excited to continue that work and to do more with it.
Yeah, absolutely. And I also have gotten to try that experience myself, and it's very cool to feel, I've never been in an actual glove box myself, but now I can say that I've felt it. So I have some experience with that now. And for all of our panelists here, we have, our gloves that we have in our office, and there's access to those gloves that they have as well. But a lot of the development can actually be done on controllers. Probably like 80% of the development path can be done with handheld controllers like this one. However, when you are developing with controllers, the experience and the best practices you have, some of the tools you need to use are a little bit different than if you're developing for gloves in the end than if you were to develop for an eventual controller use case. So that's something that we're going to talk a little bit about. What are those differences? What are some of the best practices there? And going through some of the projects, Kip, I know you have some specific objects and interactions that you had to think about this with, first with controllers and then with gloves in the end in mind. Can you tell me a little bit about some of those interactions?
Oh, sure. The development cycle was really interesting, and the first thing we had to sort of overcome was not being able to have direct access to the gloves. We worked. The development cycle was a lot from our homes and from our office here in Kirkland. You can actually pop the next video up here. You guys have a simulator that's controlled by these Vive controllers. So in this case, there's about 5 different poses that you can scroll through. And then as you sort of squeeze the trigger, you can, kind of activate the natural grasping motion of the hands here. And that really got us a lot of the way down the road with developing Infinite Kitchen Touch. And so, yeah, you can go to the next slide here. One of the interesting interactions in the experience was being able to turn on this faucet, and it has different sprayers on it, and you can feel the water hitting your hands, and you can put soap on your hands. And here I've turned on the debug visualizer, so you can actually see which of the actuators, I'll call them, are being activated by the collision particles. And we know that using if you put collisions on a particle system, that's very expensive. So there's like a secondary kind of simplistic collision system, which are these spheres coming out of the faucet. And I've just turned them on so that you can see them. And so those are sort of hitting your hand, and they're not nearly as expensive, and you can kind of see how they interact with the hand. So that was, I think, I would have to say, like, the most fun part of this experience. And you guys got to see that at AWE. We actually showed the project at AWE this year, and people love this. So it was really, really interesting. You can go to the next slide. There's also, as I mentioned, kind of deformables. So this was like the egg problem. And so just creating meshes that have different deformation states and how exactly to activate that. And that was kind of one of the more challenging things. I think honestly, the egg is easier to grab when you actually have a hand-tracked controller. And here's me actually cracking an egg at home and recording the sound of it. And also, I'd have to say, like, adding realistic sounds to these experiences greatly enhances how the mind believes what's happening. And I think just the sound of an egg cracking in your hand when you feel it is, it's very convincing. And yeah, it's just super, super interesting interaction. You can go to the next slide. Another kind of challenge that we had was just creating product avatars. And what I mean by that is, I think you can go to the next slide there, next video. Yeah. So we have a library of 3D digital assets, and some of them are even available online for people to use. But the concept of creating functional 3D assets that actually operate and feel like on this mixer, we actually made it vibrate, made the sounds so that it actually sounds like the real thing. All the buttons work. It even mixes up whatever you put into it. And in this experience, you can do other things like bake a cake. And a lot of discussions around surfaces too, like how can you create with the limited sort of resolution of the gloves, how can you create a realistic feeling of a surface? And I think part of that can be achieved through audio and other things. And I know you guys are also sort of working on something to help enhance that, maybe.
Yeah, that's definitely one of the things we're more excited about with our G1 product line, our Haptics gloves G1. This is our first full commercial product line that's not a development kit. And what we are doing with this specifically, we have what we call vibrotactile and that's where we can actually flutter the tactors very rapidly to create a vibration. And when you run your hand across something, a surface, what actually happens is you feel a little vibration in your fingertips, and that's what we're simulating. And I've tried this myself. It's really cool. It was something we weren't sure how well it was going to work. We did the research and everything, but once we actually tried it, it was really, really cool. So we're very excited about that.
Yeah, that's so interesting. And I mean, I think just trying to, with respect to digital assets, we've had a lot of conversations around how do you sort of include the haptic elements of materials on 3D objects, in addition to like how they function. And so that's kind of been an interesting conversation. And yeah, kind of really curious to see how that comes out. Some other kind of interesting challenges for us were just looking at collision meshes. Like you could show the next slide. One kind of simple but challenging thing was this milk jug. So this thing is in the fridge, and you have to. We made some activities in the study that you had to do, and you had to pull out certain elements and pour liquids into a bowl. And so just grabbing certain things is a bit challenging. So one of the things we did was take this collision mesh and just make the handle bigger, and really have to pay attention to scale. Like sometimes if you're not, without haptics, you can kind of cheat on scale, but it's really important that things are actually human sized if you're going to be interacting with them. And then this scene also shows some of the parameters, some of the HaptX parameters on the SDK, as well as some of the Unreal parameters that we tweaked on every object that was in the prototype.
Yeah, we have things within our SDK that allow to help out with grasping and how different objects feel. And we kind of have some global parameters, but then we can actually tune those on a per object basis so that we can really dial in how something feels and interacts with the hands.
Yeah, so cool. And just the last thing, this is kind of my favorite part of this project, is just the audio. It was really interesting when we started, testing the kitchen. It just felt a bit empty. And then as we started to bring in audio, it just really came alive. And it's kind of funny because that kitchen sounds exactly like my kitchen, because I personally recorded all the sounds, in there. And it was also interesting just approaching audio just, from a, just a pure recording perspective. Like at first I was recording things in a super tight way and like compressing them and making them super quiet, like in a studio would. But then we realized we actually really needed to capture all the noise, all the room sounds, like the clock, the refrigerator going and all that. Once we kind of layered all that in there, it became much more believable. And the haptics actually really come alive. And I have a video of me just recording, like rubbing my hand on countertops, trying to capture that to see if we could play it back when we're touching certain things. So I don't know, it's a multi-sensory experience, even though it's kind of haptics driven in a way.
Yeah, I've often found when I'm developing things and I have people test it out and see, how does this feel? And they're like, oh, something's missing. Then I go back and add the audio and they're like, oh, it feels amazing. And I'm like, I haven't changed how it feels. It's just now it sounds different and it just engages more of your senses and everything comes alive, like you said.
Yeah, awesome.
Yeah, and that's definitely something we see across a lot of projects is if you put in the audio, it's not quite right. If you put in just the touch, it's not quite right. You put them together and it's just this amazing sensational experience. No pun intended. And that's true of a lot of projects. Going back to the other example, we have Chris could talk a little bit about some of the objects that he had. There's some zippers and some files in the glove box that people are trying to interact with while they have the gloves on. And can you just share a little bit about how you went about making sure that those objects felt right?
Yeah, so for the busy board part of the glove box, we wanted to be able to let users acclimate themselves to using a glove box in a training environment, using the gloves. And so one of the first tasks we looked at was making a busy board. If we put those on screen. So if you see on the screen, the busy board's on the left. So actually one of the first things we actually hit was the zipper on the right. That was one of the first objects that we created for this busy board, and it basically dictated our production flow for a lot of how we would handle creating mechanisms inside haptics while we were working on Unreal, and understanding which parts of the haptics experience we wanted to accentuate and tune per various objects. So like previously mentioned, like haptics has a lot of user helping assistance tools. So like grasp, I believe they call it grasp assist, force grasp and release ratio that basically lowers the amount of force required to grasp objects and lower the amount of force that objects slide out of your hand, which was very helpful for these very small objects on the busy board. We tuned this for certain objects, sort of like the zipper. The zip itself was very small, so we had to increase the amount of assistance we had for that. And generally, we saw that separating out the physics from what is being visualized helps for developers can do more on the back end with that separation. So perhaps the zip, we want the actual collision of the zipper to be a little bit bigger than what's seen on the busy board itself. And so users will have an easier time working with that. And that also lets us work with adding other features like better haptic feedback or audio cues with that separation. Makes it a lot easier to handle that logic in the back end.
Absolutely. That I've also tried the zipper, and it's like totally different from anything in the kitchen too. It's a different haptic experience, different to develop, I'm sure. And in the glove box, something else that's like really compelling about this experience is that there is the opportunity in some parts of it for multiple people and multi-user experience in there, so you can train two people together. Can both of you share a little bit? And Andrew, you've had a lot of experience with multi-user development too, so feel free to chime in here on the conversation. But just some tips or important things to think about when developing for multi-user.
Yeah, and if I can interject real quick too, just to give a little more context on why we went down this path with the busy board itself, and then eventually the multi-user. So when we're thinking about this busy board, it actually helped us a lot. And we can actually go to the busy board image again. Thank you. It really helps us a lot thinking about, again, those small, very tactile things inside of something like this. So in a real glove box operations, tweezers are very important. They're very small things that need to be picked up and used in those types of situations. So the busy board in particular is an Alzheimer's busy board. So there's a lot of research behind using this in particular. And to give you more context here of our overall project, so this is a 2-year project that we're working on. The year one of this, and it's all research based, so it's all research funding. So year one is to be able to show, is it something that is possible? Which, obviously with, the great examples that have been shown so far today, there's definitely different applications for this. But for us as a manufacturer of certain things, we wanted to make sure the application was there. Year two is actually going to be us bringing in about 35 of these glove box operators into our facility and actually doing some true testing back and forth with them between a real glove box that's going to be inside of our facility, and then with this virtual one that Chris and the team at UCF has built. And again, being able to do that comparison between the two, and the hope of all of this would be to eventually be able to actually use this inside of our production facility, which again brings up that multi-user capability. Because a big issue that we have today is the fact that training takes a long time, because it's a lot of watch and then later on do, where this could be something where we can have folks come in initially fresh out of school or whatever it might be, and get that hands-on training without having to stop work inside of our facility. So again, this is going to be a big thing to help us as we move forward. So I'll stop there, and Chris, definitely would love to share more with you all about how we achieve the multi-user experience.
Thanks, Austin. I think that context is very, very, very helpful. Chris, if you want to share a little bit about that multi-user experience, any best practices, tips when you were doing that, and then Andrew, feel free to chime in too.
So working with simulated physics over multiplayer is a well documented, like, complicated task within just software development. And a big trick that we approached was trying to simplify what part of physics is synced up between various users. So with us at UCF over in Florida, working with Austin, several states away, we had to make sure that objects would sync up between our various clients and would look right as we passed objects to one another. So basically, one of the main things that we did initially was actually working with the starter projects that Haptics provided for Unreal as part of the SDK. A lot of those objects had a lot of good default settings for replicating over network to multiple clients, and allowed us to do a lot of very good simple testing without needing to spin up complicated network systems. We could just do it with very simple local LAN networks, and just be able to rapidly iterate. And that's also generally a big assistance as part of testing, can we go to the next slide, is that a lot of be able to test quickly in multiplayer was a big part of be able to iterate on the project. So setting up network connections with each other, setting up being able to pass projects to one another, and also without previously mentioned the haptic gloves could also work with Vive controllers to be able to let users who don't have haptic gloves test with the haptic glove users and to be able to interact with each other, which was a big help in letting us test with multiple users, with us who did have a glove, us that we had one pair, and then another user over in Tennessee that didn't have a glove but had Vive headsets.
Yeah.
And if I can jump in as well, so especially with the multi-user across the network, again, that's a huge challenge that's for us as well because of, again, with UCF and then us being outside of our usual secured area, we can do certain work together. But another thing that we're really looking forward to is doing this type of work in a more secured environment, right? So being able to have that capability and be able to show that it's possible starts that conversation for us with our stakeholders. Okay, now we can show it's possible to do this from a distance, but now can we start thinking about how do we bring this into a more protected, secured network? So that is something else that we're also very excited to again, partner with UCF on to figure out those things on how do we now bring this into a different space.
That's great. Great context to all of those tips and multi-user with different environments. And Andrew, I think you can show us some of the tools that you can use and that I'm sure Chris used and others use to help with this multi-user.
So I'm going to go ahead and I'm going to open up our Unreal Starter project here to help out here. And I'm going to go into our Haptics hand. Let's start here. And what we have here is the blueprint for our Haptics hand. I'm going to zoom in a little bit on it. And our hands are going to automatically be networked across or replicated across the network. We've got that built into the SDK so that all the clients are going to see hands in the same place that the server does, and those are all going to be taken care of for you. Similarly, any kind of grasps and things like that are going to happen. We also have this physics authority zone that I'm going to zoom out just a little bit so you can see. And we can actually change the size of this as needed. And this is just kind of a trigger to say, now you're interacting with something. This is an important object. So when we have something that is simulating physics and it is overlapping with this trigger, now we start sending network information about it across the network. Obviously, networks are limited in how much information you can send, or everyone would just send everything all the time. And we don't have that luxury, so we have to kind of limit and selectively pick what we send across. So we also have an actor in our starter project that's called a static mesh replicated actor that is already set up with a lot of the settings on it for replication that we find work quite well. Specifically, it's set to overlap this physics authority zone, since by default we have most objects ignore that. And that tells it what to network and what to sync. And for my development, mostly I use this as kind of a base class and then build any more logic on top of it. I change out my static meshes to be what I'm actually want to be networking, and then I start using the built-in Unreal, the multicasts and the replicated variables to build out the logic attached to those items.
Question.
Yes.
If I can ask you a question.
No problem.
Does this, it's called the physics authority zone.
Mm-hmm.
Does this also kind of like prioritize the network traffic as well, or the network replication across multiple sites?
Yeah, basically, those items that are within that authority zone are considered to have priority.
Okay.
So those are the ones that are going to get network updates more frequently. essentially anything in that will eventually get updated as network traffic increases. Updates become more spread out. Like if you have lots of objects that you're trying to update, you're not going to get an update every frame or even every other frame necessarily, but it will get that update.
Okay.
So you might start to see a little snapping and popping, but what's happening is the client side is also trying to simulate the physics, and unfortunately, physics engines are not deterministic, so they get out of sync very quickly. But if you only have a couple frames, it's usually not noticeable.
Yeah, I mean, I think about even application and co-presence would be kind of interesting, like sharing the objects together, being able to, you know, touch somebody's hand from a remote place or hand something. That's so interesting.
You guys were at AWE where we were showing our multi-user haptics with our blocks and everything. And people are high-fiving and shaking hands and doing weird things. And
I know we were talking, you know, before we went on the air about audio and all the aspects of audio. But I was kind of curious. I know most of the audio in the Infinite Kitchen Touch experiences, you know, provided through Unreal. You know, basically calculating the velocity of, you know, when two objects collide, and you know, playing the sound louder, playing different sounds or whatever. But like, is there an aspect to the SDK that involves triggering audio as well?
Not specifically. The SDK, we have a lot of callbacks and things like that on our haptic effects.
Okay, so they can be like event-driven.
Yeah, they can be event-driven. So when you have an event that happens that you want to play a haptic effect, it can also play your audio. It can also trigger any number of things. So, you know, if you had a hammer and you bang it and you want to play a banging sound, you can also at the same time play a haptic effect so that you get a vibration in the hammer or a thump kind of that you feel.
Okay, great.
Those were some really great tips, and I think it was really helpful, at least for me, to walk through and see the actual SDK as you were describing the tips and as you're describing the different tools to see it. For anyone watching, if you're interested in downloading the SDK and being able to see what Andrew was talking about, being able to develop with controllers, as we've all talked about doing throughout this panel chat, you can go to haptx.com and contact us to download the SDK and start getting developing and learning more about what all there is. So you all gave a little bit about walking through different objects in your scenes, but I'm just curious, through all the experience that you've had for, you know, Austin and Chris virtually too, what is like one big piece of advice that you'd give?
Well, I would say you kind of have to think about developing for touch a little bit different, because you're interacting with the world in a different manner. Like when you're developing a VR app that's just using controllers, you're going to usually just point your controller at something, pull the trigger, and pick it up. And that's it. But that's not how you actually interact with the world. When you pick something up, you pick it up, you hold it in your hand, you feel it. And then there's other things, like I have this mouse here, and when I press the button on it, I feel that click. There's a definite click. You hear it, you feel it. And that's one of the things we can actually replicate, and it feels great because we have what we call haptic effects. I kind of alluded to this earlier. And this is actually just an effect that we play on top of the regular touch. So detectors would be sending touch information, then I would press the button and fire an event that plays a haptic effect that I can now feel this haptic effect kind of layered on top of the touch and feel that kind of click. And then along with the audio, hearing that click, it's a very convincing, very, you know, tactile sensation.
Yeah. I think just to riff off of what you're saying, one of the challenging things that we had in the kitchen was the mixer. So that thing has like three or four positions to it, and so it was a bit of a challenge to have what perceived resistance on those kinds of things. So you have you kind of push it, and then it needs to stop, and then you need to push some more and go to the next lever. If you've ever played with one of those, what are they called? Those big metal mixers. There's a name for it.
I know
Anyway.
what you mean.
Yes. It's a
Like
slip of-
the brand name you're talking
yeah,
about?
yeah, yeah.
Oh, yeah. Like
Anyway,
KitchenAid?
KitchenAid. That's
Yeah.
it. Thank you. Yeah. But it's really interesting, and that's kind of an engineering challenge in a sense. Is like something that doesn't just press and make a sound, but it actually stops, has natural stops. But you don't want to just press all the way through the range, you know. So I think it's like involving some timing and things like that. And if I could chime in, like I had a couple of thoughts, just that came to I think our team during this development process. The one thing that really stood out to us though was like, okay, this is a really powerful medium, and it surprised us. Like, you know how I think a lot of the team were a bit desensitized to the power of VR. Like, we understand you don't hit things, you don't run into the wall, but like when there's this layer of touch added in, it kind of surprised us. Like I remember one day I was like, okay, I'm gonna take a break, and I went to set my controller on the table. Well, it just fell the whole way down to the floor because, in my brain, I was fully convinced there was like a surface there, and several times I found myself like leaning on something, just expecting it to be there, but only my hands could feel it. My body couldn't, and so it's like the brain's not sort of like desensitized to that medium yet. And it's almost like watching, HD TV for the first time. It's just like really, really interesting and engaging. And just building experiences for this has been super fun and really interesting for our team. And then another aspect of this that I feel like there's like all these kind of like areas that I think are unexplored. They're a lot of fun, like UI. So touch-driven UI in 3D space is kind of just this whole new area. So we went through a lot of iteration, like, changing the kitchen around, changing the cabinets and the surfaces. And we kind of had a lot of debate, like, oh, should we put just buttons right on things, or should we have a UI on the, on the wrist or whatever? And, it just became obvious, like you could actually have UI that's out of your view, just like in real life, when you just reach out and, you open up a drawer and you pull out a fork or something like that in your kitchen. You don't even have to look at it, So there's this whole new kind of like dimension of UI that I think was interesting to explore. And I feel like we haven't actually really, touched it too well. But and my last, like if I were giving somebody advice, I think in just, kind of similar to what you're saying, just to be like holistic about the the assets themselves, like how you light things, how you weight things in a digital sense. I mean, the controllers, they have resistance, right? So you get a sense of like weight in a way where it will pull back on your finger, but you don't get a sense of like the weight of objects itself. So there's ways I think that you can kind of impose that a little bit.
Yeah, you can trick the brain a little bit.
Yeah.
There's some neat things you can do. It's amazing how much you can fool the brain. I know you mentioned dropping the controller. I know I've been working, had a glove on in one hand and another hand that I can reach a mouse or something. Then I go and reach to grab something in VR and like, what? Oh, I don't have my other glove on. I can't.
I have also done that. And I have leaned up against the table in front of me that doesn't actually exist. I've definitely done that. Austin and Chris, I want to know what you both have to add to.
Yeah, I think something that's really big, at least for us, and then also, so my background is instructional design. So I've been an instructional designer for about a decade now. So always thinking about that end user and that end user experience. So very similar to what Kip has been saying and Andrew as well, Joe. So something for us as we're building these things out, just continually thinking about, how does this help, any type of potential problem? How does this solve any kind of issue when it comes to our customer, or that trainee, and then also getting that feedback from them too. So that's something that's, it's an iterative process, right? So we're continually, between myself, Chris, and their team, and then the folks that are here at Ordic, and it's a constant round robin of, hey, let's try this out. Let's send a new build. Let's try this. Okay, we got some feedback. Let's go back and do something different to make sure that it actually fits the need. Because we all, I think we've all been a part of projects where we built something or created something, and we were in kind of a silo, and it's because we didn't get a chance to really, give it to that customer as we were building it. It may or may not have been exactly what they needed. So I know, at least from my end, again, from an instructional technology standpoint, always making sure that customer and that that participant is always in front of mind and always involved in the development is very important.
That's a great one. As a product manager, I know that one all too well. Gotta always keep keep the end user in mind. Chris, do you want to add anything, or we can move to audience questions?
Yeah. So I think especially for development, I think a thing to keep in mind is sort of keeping your try to work towards a simple design scope, especially as you approach physics. The haptic gloves can balloon into a complicated question and answer for developing any product, in especially inside. But if you tend to simplify a lot of physics, especially just working in a lot of like local physics, a lot of the math just becomes a lot easier to deal with. There's a lot of inside a lot of the engines, so in Unreal and Unity, a lot of them have like physics constraints that can let you like constrain objects to certain axes of movement, certain rotations. A lot of those helped a lot for making a lot of mechanisms that moved around and moved in intuitive to end user experience. A big trick is you don't need to one-to-one map a lot of the physics. You just need to approximate it, abstract it. Think about like a lot of entry level sort of physics approaches to a lot of these issues, and you'll often find a lot of those kinematic physics works for developing a lot of insight with haptics. For a lot of users, a lot of them will think kinematic physics is good enough for what I'm expecting physically.
And that is a good point. You mentioned the constraints and joints. And we actually have a number of things called haptic primitives that are built off of the physics constraint and the joints in Unity that kind of approximate things like buttons and dials and switches and allow you to implement those a lot more easily, and then have functions attached to their different states and positions and things like that to make it easier for developers to leverage that, because constraints are kind of unintuitive, unfortunately.
Awesome. That I think all of those were super great last pieces of advice there. And we have it looks like we have a few questions from the audience. The first question looks like it's was asked when Kip, you were talking about your project, so targeted mostly at you. Andrew, looks like there's some opportunity for you to have some input here too. But if the parameters are set per objects, and if someone changes the scale, would it still react to the preset parameters?
I think so. I'm pretty sure the Unreal, physics parameters definitely apply as you scale. I'm trying to think of something that wouldn't. I don't know. You tell me. Like,
if you haven't overridden the mass will change when you scale something, which then also kind of trickles down into things like constraints and stuff like that, because the mass is factored into forces and constraints. As far as our haptics, changing grasping properties and tactile feedback properties, that's not going to change. Like if you have an object that you want to be kind of squishy and you've turned off force feedback for that object so that you don't get that resistive force from your from the tendons on the back, that's still going to be turned off no matter if you make it larger or smaller or whatever.
I guess if something gets a lot bigger, it's going to be harder to grasp. So in that sense, the scale changes, but the parameters maybe don't as much.
Okay. We have another question for Andrew. Can you also simulate the pressure of grabbing an object that is also interacting with a separate object? For example, the pressure of grabbing a paintbrush that is being pressed and dragged against a different surface, like a canvas or walls.
Yeah, you can. Because what's going to happen is when you have that object and it's pushing against a surface, it's also pushing back against your hand like that. So you're actually going to feel some of that. And particularly if you have a rough surface, like I've got my finger out, and you bump over it, you will get some of that sensation because it's going to bump in the physics engine and change the force and distances that are being calculated for the tactile responses. So that's a good question.
Yeah,
that is
we
a good
can,
question.
We can capture that.
Yeah.
And we can fine tune that more too, so that if, for instance, if the tactors are all the way inflated and you try and inflate them more, they're all the way inflated. But if they're only a little bit inflated, they're not fully inflated, then you can always add more feedback to it, essentially. So if you're expecting something's going to be bumping into things and stuff like that, you can pull the inflation parameters down just a little bit, so that just grabbing them and have a normal loose grip wouldn't fully inflate them. But if you squeeze tighter, they'll inflate more, or if you bounce it against something.
Yep. And this question actually is a great example of something where having the combination of the tactile feedback that actually displaces your skin and the force feedback combined enables this to happen, so that it can actually, as Andrew was describing, can actually inflate those against your hand. And looks like we have another question for Andrew. Can you describe the level of fidelity of the touch experience, for example, smooth stone versus rough stone versus wood?
Well, in DK2, that experience, because we don't have the vibrotactile in our DK2 units, so we really can't simulate that too much. There is a certain amount we can simulate. If the stone is particularly rough, we can get some feedback as far as it being different and having different heights and stuff. But as we go into our G1 products, we can define waveforms and things like that for different objects. And we're still kind of figuring this out too, because this is new to us too. Nobody's ever done this. So to try and figure out what the right combination of frequency and amplitudes and waveforms are to convey a rough wood surface versus a fabric surface versus a stone surface is going to take some trial and error. And we do want to include examples of those as we roll out our next SDK.
So would that be coming through on something like a normal map instead of just the physics, the mesh of the object? Would it be a material that feels that way, not necessarily the...
We're actually talking about having essentially a texture-based thing that we can apply to an object that you can then sample. That way we can not only feel, as we move across an object in one direction, feel a surface like you'll have wood. Wood has grain, and in one direction it feels kind of smooth, but then you run against the grain and it's much more rough. And we want to be able to capture that. And by doing a texture-based lookup, we can look at the changing values in this texture and have it actually be separate from what the normal map is. So we could even define more unique values.
Wow.
There's
awesome.
a lot of opportunity in
Yeah.
vibrotactile work. We have a lot of conversations about what are we trying to do? What can we do that we know we can do now? What do we think we can do in the future? And just like big brain thinking about
super
it.
exciting.
Very exciting.
Yeah.
So I have one more question that is for each of the panelists, so you can each answer it. What are some of the potential applications that you foresee in the near future? And I'm going to start with Austin.
Yeah,
What's your thought?
that's great. It's great. It's a great question, and I'm actually really excited to talk about it a little bit. So, one application which I think Haptics is already using this for, and I've actually had a chance to see it once or twice, is robotics. So, being able to use these gloves for distance, certain things for distance as far as the manipulation of items, which is again a very important thing for us working in manufacturing. Again, being able to be away from certain things at a distance, super important. I took a note here of a few other things. Another one being, for firefighters, which I think there's already a simulation that has been created very similar to that. Or, you have the truck and you're doing certain things with that, which again for us very important. And a lot of what we do is, is emergency response, things like that. The last one I will say I think would be really important for us is for people that are in emergency response, as far as like CPR, things like that. So being able to feel a certain amount of pressure if you're pushing down virtually on someone's chest if they need CPR, those kind of things would be very important for us. Or to be able to do like your open field training and you have to do a tourniquet on someone's arm or leg, things like that. Those would be, huge for the things that we're trying to do in the near future.
Yep, those I was listening to you talk through those, and I'm like, yep, yes, those are all great areas to go. Kip, I'm going to go.
Yeah, honestly, it's a tough question. I mean, we have to take into account a lot of really big companies are really investing in sort of the virtual future in a sense. So like we want to take advantage of that however we can. I think as far as haptics go, there's obviously training applications. There's plenty, there's all kinds of specialized training that we do in the store with our associates. And of course, learning how to use things for our customers as well. And as I mentioned before, just figuring out new ways of, allowing our customers to engage with products in the home, I think will be a huge application. And I'll just give a little plug for one of my favorite books here, because it's kind of futuristic in a way. It's Haptic Sensation and Consumer Behavior by Margot Raquette. Super interesting book. It's influenced my thinking in this space a lot. And there's a lot of cool studies and information there as well. But yeah.
Awesome. Those are great too. What about you, Andrew?
Honestly, I think things like design review is something that we haven't really talked about here too much, but it's a big interest. Being able to kind of design something and bring it in to a virtual environment and have people from all over the world interact and reach out and get a sense of the space, whether it's a vehicle or aircraft or something they're designing for in home, any kind of machinery, being able to be in that space and get a sense of scale and being able to reach out and very accurately know where your hand is, where your fingertips are, how things feel, how it feels in your hands. Is this the right thing? Because, we're building products here too. And it takes a lot of time, a lot of energy, a lot of money to build prototypes. And if you have something wrong, you lose a lot of time. So you want to make sure you get it right. And the more tools you have to get that right, the better off. So,
it's much better to find out that your button is an inch off or a millimeter off in VR when you're able to just move it a little bit than when you've actually made the
go back into your
model.
SolidWorks and say, okay, we can change this.
Totally. Yeah. So everything we've talked about, with all of the different tools, the stuff Andrew showed, that all of the panelists have talked about, all these great tools for adding haptic feedback, again, are in our SDK with the Unreal and Unity plugin and the C++ API. And if you go to our website or contact us, HaptX, on LinkedIn, you can contact us to find out how you can try either the gloves and download the SDK if you're interested in that as well. Thanks again, everybody, for joining us. I think having a panel with people who are working on such different projects but such important projects is really great and really adds to the conversation. And I'm going to pass it back to Nate.
Thank you.
Wow. Yeah. Thanks, Caitlin, Andrew, Austin, Chris, and Kip for the amazing discussion. I don't know about the audience, but it's really interesting to think about how much we take for granted the feeling of touch in just everyday life and just as we go about our day. And then as soon as you don't have that in VR, it becomes obvious like how important it is in so many different ways. And so it was really insightful. Thank you, everyone, for this discussion. And that's all the time we have for today. However, please get in touch with any of the panelists on LinkedIn. They're inviting you to reach out, connect, and learn more about the work that they're doing. So don't hesitate. Don't be shy. And if you missed any of this session, you can rewatch it on demand on the AWE LinkedIn or YouTube channel. And so thank you all for coming today. Have a great rest of your week, and we hope to see you soon.